All right, so we made it to the time problems, and these are always the hardest. And so this video is probably going to be the longest. So the first thing I want to talk about is in each of these kinds of problems, you're going to be dealing with a distance, a rate, and a time. Okay, and so the formula dealing with distance, rate, and time, ooh, that's a highlighter, is D equals distance equals rate times time. Okay, and so when we're trying to set up an equation involving the time, we're always going to be given information about the time. And so we want to solve this equation for t by dividing both sides by r. And so the thing you have to remember in each of these problems is t, time, equals d over r. Okay, put a box around that, put stars, highlight it, write it in a different color. T equals D over R. D over R. Okay, not R over D. Okay, and so let's start with number 9. Jason drove 50 miles at speed X and then increased his speed by 10 miles per hour for the next 100 miles. The entire trip took him 2 2/3 hours. There's the sentence about the time. You're always going to be looking for the time. So you're looking for a unit that measures time, like hours. Okay? And so how fast was he going on each part of the trip? And so the equation we can write is that there's 2 parts, the first part and the second part. So the time for part 1 plus the time for part 2 equals the time, the total time. I'll just put T total. Okay, and so this 2 2/3, you don't want to work with mixed numbers, and so you need to convert that to an improper fraction. You do the 3 times the 2, which is 6, plus the 2, which is 8, and so 2 2/3 is the same as 8/3. That's a trick from like elementary school. 3 times 2 is 6, plus this 2 gives you the 8 over 3. Okay, so I know that time 1 plus time 2 equals 8/3 hours. And so now we need to replace these t's with d over r. The distance for time 1, d1 over r1 plus d2 over r2 equals 8/3. All I've done is replace these t's with d's and r's, and I kept the notation of sub 1 and sub 2. Okay, so now that you've got this set up, you want to replace d's with the given information, and you want to replace the r's. And so going back to our word problem, it says Jason drove 50 miles, that's D1, at speed X. That's the rate one. Then increased his speed by 10 miles per hour. Increased. That means add. So he increased that speed of X by 10. So that's our R2. For the next 100 miles. That's our D2. All right. So the final equation we're trying to solve here is, I'll keep using blue, 50 over X plus 100 over 10 plus X. Nope. X plus 10. It's technically the same, but you'll see why that matters later. And then equals 8/3. And so it's really hard to just jump to this blue equation without going through the T's and then the D's over R's. You're always going to be given this sentence about the time. And so start by writing an equation with T, replace it with D over R, and then you can fill it in with the actual numbers. Okay, and so this is the equation we're solving, and so we need to get a common denominator across the board. Okay, so this fraction needs a X. This fraction needs an X plus 10. And this fraction needs both. And both of these fractions need a 3. They all need a 3, they all need an x, and they all need an x plus 10. And so now we can ignore this big ugly denominator and just focus on the numerators. So this first numerator is 50 times 3, which is 150, times the x plus 10. I'll distribute that later. Here we've got a 3x times 100, which is 300x. And then over here, we've got 8x times x plus 10. All right, so let's take care of the distribution. So I've got 150 times the x times the 10 plus 300x equals, this gives me 8x squared. I don't want to do that line, it looks like division. And that gives me 80, gosh. Okay, so now we have a quadratic to solve. All right, so we need to combine some like terms. We've got 150 and 300, that's 450x. And since it's a quadratic, we want to get everything on one side. Okay, and so I'm going to move everything over here. And so that gives me 8x squared. And then we're subtracting 450 from 80. Which is negative 370. And then subtracting the 1500 from nothing. All right, so we've got a really ugly quadratic. And you can use your calculator to find the solutions because we're not really testing your ability to solve quadratics here. So I'm going to type it in and see if I can quickly find the solution. If I can't, I'm going to move on to the next problem so I don't waste your time. All right, so what I'm doing is I put it in y equals, and then I'm looking for the two places it crosses the x-axis. One of them's negative, and so I'm not going to use that as part of my solution because it doesn't make sense in this context. We're not going to have negative answers. Okay, and so negative, ignore the negative. And then the positive answer is 50. Okay, so x equals 50 would be what we want to use for this answer. Okay, so now that we have x equals 50, we need to answer the actual question. So let me get a highlighter. The actual question says, how fast was he going on each part of the trip? Well, x was just the first speed. On the second speed, it was 10 faster. And so for the first part, it was 50 miles per hour. And then for the second part, it was 60 miles per hour. And so on a test, if they're only asking for one or the other, make sure you give them the right answer. If they said, how fast was he going for the second part of the trip? You would want to type in 60, not the 50. You'll miss it if you just type in the 50. Okay, so let's set up 10 and 11. Remember, you're always looking for the sentence about the time. Karen can row a boat 10 kilometers per hour in still water. In a river where the current is 5 kilometers per hour, it takes her 4 hours longer to row a given distance upstream than to travel the same distance downstream. Find how long it takes her to row upstream, how long it takes her to row downstream, and how many kilometers she rows. Okay, so it's always going to seem overwhelming at first. Look for the sentence about the time. Okay, and so when I look at this sentence again, the sentence about the time is it says it takes 4 hours longer to row upstream than to travel the same distance downstream. Okay, always look for hours or minutes, a unit of time when you're looking for that sentence. Okay, so 4 hours. And so this time, they're not giving me a total time like they did in number 9. They're giving me a comparison. Okay, they're saying it takes 4 hours longer to row upstream. And so the time it takes to row upstream is going to be 4 hours longer than the time to row downstream. So the equation I'm setting up with T, instead of this T1 plus T2 equals T total, I have T up equals T down plus 4. Right? And so now I can replace that with D over R. So D up over R up equals, not T, D down over R down plus 4. Okay, and of course it's going to take longer to row upstream because when you're rowing upstream, you're going against the current. So it's harder, okay? It's much harder to row upstream than downstream when you're going with the current, okay? And so now it says we're rowing the same distance, and so we don't know what that distance is. Okay, we just know it's going to be the same. And so instead of specifying D up versus D down, we can use X for that. Okay, so it's going to be the same in both. Not plus, sorry. And then for the denominator, it says this is going to be our rates. Okay, so we're looking for the rate upstream versus the rate downstream. So it says in a river where the current is 5 kilometers per hour, it says she can row 10 kilometers in still water. Okay, so in both cases, she's going to be rowing 10 kilometers per hour. But in one situation, she is rowing upstream. Okay, and so that current is working against her. So I'm going to subtract the 5 miles per hour from the current from her speed. She's only going to be going 5 miles per hour. In the situation where she's going downstream, I'm going to add the current to her speed. So you either add the current if you're going with the current, you subtract it if you're going against it. So in the case of going upstream, she's going 5 kilometers per hour. In the case of going downstream, she's going 15 kilometers per hour. Okay, and so this is the equation we want to solve. Okay, you're going to have to get a common denominator and solve for x. Okay, and then for problem 11, it says train A is 15 miles per hour faster than train B, whose speed is x. Train A travels 430 miles in the same time that train B travels 355 miles. What is the speed of both trains? Okay, and so this time the sentence about the time comes right here where it says same time. So it says train A travels 430 miles in the same time that train B travels 355 miles. Okay, so this time we're going to have time, I guess we'll use A and B. Time A equals time B. Okay, so in question 9, they gave me a total time. So time 1 plus time 2 equals the total. In question 10, they gave me a comparison saying the time upstream was 4 more hours than time downstream. And then in number 11, our sentence says it's the same time. That's why they're set equal to each other. Okay, so now we can replace that with D over R. And then fill it in with the information. So train A is 15 miles per hour faster than train B, whose speed is X. So I know the speed of train B is X, and I know train A is 15 miles per hour faster. So that would be X plus 15. Okay. And then it says train A travels 430 miles in the same time that train B travels 355 miles. So the equation I'm solving is 430 over X plus 15, and then 355 over X. Now, before you solve this equation, double check. In the place where you have a bigger numerator, you should have a bigger denominator. Okay, so when in doubt, if you don't know where to put this plus 15, put it with the bigger numerator. Because in order for these fractions to be equal, a bigger numerator has to have a bigger denominator with it. Okay, and so that's a good way to check to make sure you've got the right equation. And then this one's going to be super easy to solve. And so make sure you check the answer key, because once you find out what X equals, they want to know the speed of both trains, and so you'll have to add 15 to it to figure out the speed of train A. And then same with number 10. When you solve for this X, you've only solved for the distance she traveled. You're going to have to figure out the time it takes her to row each one. And so in that case, remember that time up equals the distance upstream, which you will have found, divided by the 5 kilometers per hour. And T down will be the distance downstream, which is the same, divided by the 15. Okay, and you'll see that in the answer key when you check your work.